Start recording. So we are live. Hello there. Thank you for joining
Hello.
me. 1 second, let me set up Jitsi so that we have this split view. Let's start with the basics. So, what is your name and what do you do in very general terms?
So my name is Julien Malka. I'm French. You can also find me on the internet by the name of Luge, which is just a nickname. So I go by whatever people are calling me. It's fine. I do several things, but my main occupation is being a researcher. I'm a PhD student in the Polytechnic Institute of Paris. So it's a university.
Mm-hmm.
I am working on empirical software engineering, so like practical research in software engineering, and my field of interest is functional package managers. So, for example, Nix is a functional package manager, and it's also what I do of my free time. So, like, I have the research area and the open source contribution area as well.
Sounds very promising, and I want to get into that because, of course, I know you from Emacs and what you do with Emacs, but eventually I want to learn about all these other things. So your research, functional package managers, Nix, all that. So let's start with Emacs a little bit. Tell me how you use Emacs, and then we go into those other topics.
Yeah. So I think I was introduced to Emacs by friends at my research lab. And like for me, the selling point at the beginning was you can take your notes in Emacs with org mode and make relationships between the notes and everything. It's good for like to help you reflect on your ideas and stuff like this, to take a lot of notes. So I was kind of wanted to try this. So I installed Doom Emacs. And then I figured that I could do more and more things inside my Emacs and connect all those things. So maybe I would answer my emails, I would program, and maybe some email comes into a note, so I can do a relationship between the email and the note and everything. And I started to understand that Emacs could take over everything and find it very powerful. And since then, I've tried to write more and more integration of my workflows into Emacs, and it's been a nice journey, I would say. Nice learning journey.
How did you find Emacs in the beginning? Because, of course, it was sold to you as basically a note-taking app with maybe superpower potential. But how did you go from note-taking to eventually broadening the scope and doing more things with Emacs? Was that natural or was it difficult?
It was difficult. I've been a Vim user for my whole programming life, I would say. So sorry, that's the cat.
That's the cat. Oh, that's cute.
Yes. You cannot do anything against the cat.
No,
he's the master of his household. Yeah. I was a Vim user originally, and so I was in this perspective of Emacs is an alternative to Vim, because it's like they were always in the my culture put one against each other, like Emacs versus Vim. So I was like, okay, I will try this thing, which is another text editor, right? And that was my perspective at the beginning, and then I understood what's the difference between Emacs and Vim, which is essentially that Emacs is not a text editor. It's like an interpreter for Lisp, and then you do what the fuck you want with it. So, including if you want, but you don't have to edit your code with it. Which was maybe the hardest things for me to transition to, because I felt like Emacs was less fast, less responsive than Vim. Mm-hmm. So I sometimes I'm still like, when I want to do something very quick, still opening Vim and doing it. But for most of the other stuff, where for me, like the selling point was really like the integration between different stuff that I do into one common ecosystem where I can simply hook into that ecosystem by writing code in just one language. And then like progressively it replaced all the standalone apps that I had on Linux that were like, you know, they had all the Unix philosophy, so they were very good at one thing and one thing. I was very happy with them, but the problem is that when you have like 10 software that are all very good at one thing, how do you connect them? And there is not one underlying API or language you can easily do that in. While if you do everything in Emacs, maybe individually each task is going to be maybe a bit less efficient than with this software that were really good and really well optimized for one task. But because it's all part of one thing, it's really improved my workflows and my way to use a computer.
Yeah. And I think I have exactly the same realization. I came from this Unix approach where you have all these standalone tools which do one thing but don't play nice in terms of adding glue code between them, to eventually having Emacs as the integration layer.
Yes, exactly.
Is there, so Emacs right now is your main interface for note-taking, but also for programming, I imagine? Or do you have like other tools?
Yes, so I have different, I have not yet completed my journey of learning Emacs in my own opinion, so I have different like level of integration. On one laptop I have XWM, so like full integration. It also manages my Windows and everything. And on my other computers, I just like launch it and it does like 95% of what I do on the computer, and the 5% extra I do it on a web browser or on Vim if I need something quick, or in a normal terminal. I like, for me, like using terminals that are inside Emacs do not always work.
Okay.
Like in a lot of cases it works, and I don't need it to be extremely fast, but sometimes I have some task where I'm like, okay, I will open a Kitty, which is my terminal emulator of choice, and just do the task in it. Excuse me for a second.
Yeah. And while you take care of the cut, just to say that I think this is a pragmatic approach where it's like, okay, use Emacs for the tasks where it is good at, and then when you need to use another tool, just use another tool. These are tools after all, not articles of faith. So.
Oh yeah, exactly. And I think when I will have also like the correct commands and key bindings and everything to make my life way easier in terminal inside Emacs, it will also be better. But like I have only some small amount of time that I can dedicate to learn Emacs and make my Emacs experience better. So it's going step by step.
Yeah. That's understandable. Yeah, because of course, just to say, the other thing is, it makes sense to bring something into Emacs when you eventually want to leverage that possibility for the interconnectedness that you mentioned earlier. You alluded to earlier. If it's a standalone task, like you want to do some compilation, for example, but you don't really care about ever bringing that into Emacs, then of course it's not a pressing issue. You can keep doing it externally.
Exactly, and that's why I think like the main vision for my terminal usage into Emacs is going to be using eShell, because then it makes sense, and I can like start a task in the shell and then be like, oh, now I want it to be inside the Emacs buffer, so I will redirect it to an Emacs buffer, or do this kind of stuff, which I think makes it very powerful and more integrated. Yeah. So that's like maybe my vision for it in the future, but I need a bit of time, so I do things step by step.
Yeah. And of course, if you are really motivated, you can write an interface, kind of how Magit is an interface to Git. Not to say that you can just invent Magit; it's not that easy. But just to say that you can have a bespoke interface to a command line tool.
Yeah. Like it's infinite in terms of potential.
Let's switch topics because, of course, Emacs, I think more or less, when we are talking about power users, is like I use Emacs for everything. That's kind of the story, right?
Yeah, yeah.
So let's tell me more about your research. Let's pivot that way.
Okay, yeah, and my usage of Emacs is very linked to my research because I wanted to have those notes and to make them in a format that is accessible to my advisors and everything, and to create a workflow where I could do research in a way that is really not only for me but for the people I work with, super fluid and everything. So that was actually my selling point for Emacs at the beginning. But yeah, so my research is I work on functional package managers. So functional package managers are like, there are two, I would say, nearly mainstream example that maybe people have heard those names before is Nix and Guix. Mainstream in terms of maybe you've heard this name, but the concepts are less well known. But they are like so they are package managers, so the software that install other software on your computer, but they are made in a very much different way to the classical package manager that there are in other Linux distributions, such as APT, for example. Instead of having like pre-built binary that you as a user will download and install on your computer, they have like concept of, instead of distributing the binary, we are going to distribute a recipe for you to compile the binaries yourself. And this recipe is written in a programming language, but a full-on programming language in which you can do a lot of different stuff. You could do things that are unrelated to writing packages, but one usage of this is write expressions that will be a recipe for your computer to understand and build a software yourself. So yeah, so the idea is that you have all those recipes and you can compile the stuff on your computer, and then there is a software distribution that you can use on any Linux or macOS computer. And there is a Linux distribution which add another layer where you can be full on Nix on your Linux.
I see. So in other words, if I understand it correctly, you can install this functional package manager on top of your existing operating system, Mac or Linux, or you can install it as a standalone operating system, a Linux system.
Yeah, and as it allows you to do more things, because it will not only manage the packages that are installed on your computer, but it will also manage all your configuration files and all your services like systemd services, this kind of stuff. So it's even more advanced, I would say, and so it's a package manager that have one goal of it is reproducibility. It tries to enable different kind of reproducibility, and that's also like one thing that I'm studying in my research, is like defining what reproducibility means and what if there are different like definition of reproducibilities and this kind of thing. And so one thing that it allows you to do is write like so on NixOS, for example, so the Linux distribution based on Nix, you write the configuration of your system in one configuration file that is written in Nix the programming language. And the idea is that from this configuration file, it will define precisely the state of your system. So all the services that are there, all the packages with their specific versions, all the configuration files for the software that you're using, everything.
And users, I imagine, and permissions and all that.
Exactly. Everything that is could be considered as configuration of the system, it can manage it. And the idea is that if you were to take exactly that configuration file and put it on another computer and install it with the same configuration file, you would get exactly the same system, apart from the data.
Yeah. Okay. Yeah. Okay.
But all the system configuration will be identical. And that's actually what happened to me like 3 days ago. My computer broke. One, like the motherboard fried or something like this, so I had to replace a lot of components. Right? Yeah, it was a bit of a mess, and so long story short, I replaced also like all the disk where Linux was installed and everything. Like I did a clean, started from a clean slate, I would say. And this kind of situation is kind of nightmarish when you are on another Linux distribution, because you can say, oh, I need to reinstall everything. What did I install actually before? So you need to remember all the software that you have. Maybe you need some specific version, you're not able to find them again. Maybe so, like getting a system in a certain state is complicated on other Linux distribution. First, because you have to know exactly what is the state you want to put it into, and then it's also complicated sometimes because dependency moves and everything. So with NixOS, what I did, I took my configuration file, copied it on the other computer, ran one command, and then tada, I was again in the exact same configuration with all my software there, all the services that I wanted running, my Emacs with the exact configuration that I want already there, everything. So that's like one of the magic power of Nix and NixOS.
And this also gives us like a concrete idea of this reproducibility that you mentioned, where basically reproducibility from one computer to the other, like given one specification or configuration, you get exactly the same results. But are there other types of reproducibility? Because I remember, for example, the Debian project talking about reproducibility in the context of security.
Exactly. So that's also that's one main aspect of my research. So what I explain right now is we could define this as reproducibility of software environments. So you have a software environment on one computer and you want to have the exact same on another computer. And this is useful not only for my purpose of having one computer that is destroyed and you want to have the same one. This is mainly useful for developers that want to work on a common project and they want to have the same dependencies, because it's like if you don't have the same dependencies, maybe you don't have the same behavior. And like it's a big problem that developers have when you come into an open source project and you want to start contributing and you see, oh, to work on this or to build, you need these dependencies, and then you have a list of dependencies, and then you try to install them, and they are not there on your distribution, or they are not at the same version are not compatible, this kind of stuff. It's kind of the dependency hell problem. And so the property that you want to have here is reproducibility of build environments. Prot are able to have exactly the same dependency and software environment as me, so we can work on the same project and have the same bugs or the same non-bugs, right? So it's cool for collaboration. But the other definition of security you're mentioning that has been or of reproducibility that you're mentioning that have been pioneered by Debian for security is reproducible builds. So it's another idea. It's the idea that not only that if you were to take a software project and you compile it on your computer, and I were to take the same software project and compile it on my computer, we get the exact same binaries, bit by bit identical, right? So this is not a given. Unfortunately, there are a lot of non-determinism in compilers, which make it so that if you compile it on your side, I compile it on my side, we don't get the same. We get something that is semantically identical, so it will, or functionally identical, so it will do the same thing, hopefully, if the compiler is correct. But maybe it's not it's not equals in the sense of some bytes will differ. And why is that bad? That has to do with the problem of binary distribution. So if I am a Debian user and I do apt install whatever package, htop, right? For example, or Emacs. If I do this, what it does, it connects to one of the Debian repositories or mirror, and it will download the binary pre-compiled for me and put it on my machine. So the big question for security here that we can ask is like, why would I trust this binary? Okay, maybe this binary was actually not is malicious and has been put on the server by a bad person, an attacker, and I'm downloading it and I'm running it, and I have just maybe executed a virus or something like this, right? So essentially what I have to do when I'm a Debian user is I have to trust the Debian servers that this is not the case, right? That the binary that I'm downloading is what you want to know is if the binary that you're downloading was actually obtained from the source code that you believe it was obtained from. So maybe you want to be sure that the Emacs that I'm downloading has been compiled from the source code of Emacs that I know and I trust, and in a server that is not vulnerable and everything. And at the end, the binary that I'm downloading is this one. So, and the problem is that there is not really a way to make, like, to have a strong relationship between the binary and the source code it was obtained from, because binary is a bit opaque, is difficult to audit. But with one good direction to improve this is using reproducible builds. So it's the idea that if Emacs, when I compile it, gives always the same binary, so it's reproducible, instead I could still download it from Debian, but instead of blindly trusting Debian servers, what I will do is I will say, okay, Prot, you also compile Emacs. This other guy that I know, you also compile Emacs, and like we have several people compile Emacs and say, okay, what I obtain is this binary with this specific hash, and because it's reproducible, everybody should agree and obtain the same hash, and this hash should be the same that I'm downloading from Debian. And if it's the case, I know that it's the right thing because everybody else agrees that I am downloading the right binary.
I see.
So if the software is bit by bit reproducible, if the software is reproducible, then we can, instead of trusting one central party when we download these binaries, we can instead kind of distribute the trust and ask several trusted parties that are independent and will not collude together to compile everything and say, okay, this is the same thing as what Debian is giving away, so we know that there is no problem.
And I imagine this can be done at the time of installing the package, where the package manager can say, okay, here is the hash, and let me check with some trusted source, and okay, and verify.
Exactly. Exactly.
So I imagine that because with the functional package manager you distribute recipes, you don't even have the need for reproducible builds in this way, at least for the local compilation. Oh, you do? Okay.
No, for the local compilation, no, which is always an option in functional package managers. But the fact is, like, compiling everything, your whole software distribution is not something you really want to do every day, right? So we also have those concepts of binary substitutors, where or binary cache or things like this. So we can fall back to the the way distribution like Debian function and download pre-built binary from a trusted source. So we also have this problem where like there is in the Nix community one main build server that builds everything, and then we can download the pre-built stuff from them, and we have to trust them that they are not doing they are not, like, we have to trust them that they are trustworthy, so they are compiling things and not trying to give away viruses, and we have to trust them that the security measure that they take are good enough so that there will not be an attacker that will steal the main signature key that signs every binary that we download, and so yeah.
I see.
It means that we still have a lot to gain with build reproducibility.
Okay. But I guess because you distribute, or rather you as a user get the recipe and you also know the source, you can audit it yourself rather than checking with some... I mean, it's easy for you to build it right away and compare.
Oh, yeah. I mean, with this recipe, I can verify very easily that I get the same binary as the NixOS cache. But I have to say that even in the Debian community, even if they don't have really this concept of like a recipe that is like their concept of they don't really have like recipe first concept like in Nix, but they still the reproducible builds community in Debian created a lot of tools that can allow you to independently verify and rebuild the stuff on your side. So like it's still possible if you want to do it.
Okay. That's good. Okay, let's switch gears a little bit, because I want to understand why is it useful to have a programming language for recipes? Why not have like a dumbed down, let's say YAML-like or TOML-like kind of thing? Why would I need the programming language? What do I gain from that?
Well, you gain. I will take an example in the NixOS world, because it will be more easy to understand. But we use also Nix to write those configuration files that are installed for software. So it's the idea that Nix is not only going to manage the software, but it can also write some configuration file for the software. And you have to imagine that the big selling point to having those software and configuration file written in Nix, which is a full-on programming language rather than in YAML, is that you can create abstractions on top of those concepts, or abstractions on top of packages, abstractions on top of configuration files, and then you can say things like, okay, if my machine is in this. If my machine is a server, then I want to activate these packages. If my machine, and so it allows you to it's like a YAML, but you can write functions, and so it allows you to have any kind of level of abstraction, and then at the end it's still a text file, but maybe it's been written by a lot of different functions that activate in a lot of different cases, so it will simplify your life at the end.
And does this language, or let me put it a little bit differently, so Nix is the package manager and also the language, so you use the package manager to write in the language the configuration file and the recipe. Does the recipe / configuration file have access to some kind of global state? Like, can you write something like, well, if these other packages exist, then I also want such and such?
Yes.
Okay. So
and you have for when you're writing configuration for an NixOS or a Linux machine, you can really write a recipe and the recipe knows everything else that is going on in the configuration. So you can say, if this software is activated, then I want to have this configuration file because I want them to talk together. If it's not active, then I don't have this configuration file. This kind of stuff. You can have this kind of logic.
Oh, that's really powerful. Yeah, of course. Because I imagine like a scenario to use Emacs, because now I cannot think of anything else. Like, so for example, let's say I have a recipe for Emacs, and optionally I have tree-sitter, right? So I have a section of, well, if tree-sitter, the library, is also installed, then also fetch these other packages from that relate to Emacs and set up my, I don't know, Python tree-sitter mode up for me or whatever.
This is completely doable, yeah.
That's amazing. Because the reason to me this sounds amazing is because if it was just limited to packages and not to configurations, then I would say, okay, it's nice to have reproducibility and all that, but it doesn't really go too far. But if you add the configuration part of it, where everything is determined in this functional way, it goes really far.
Yeah, but even for packages, like it's still very powerful. Like you can imagine a package in Nix is usually a function, like a function in a programming language. This function takes as input all the dependencies to build or to run that package, and as output it gives some kind of recipe on how to build it from those packages, right? And because it's a function, you can say, okay, I want to take the expression for HTOP or for Emacs, whatever. It has all those dependencies, so I don't know what Emacs depends on, but maybe it depends on curl. I'm just inventing here, but it's just an example. So the expression for Emacs is a function that takes curls and a lot of other dependencies and returns an expression for returns the recipe to build Emacs. And you can say, okay, because it's a function and it's not just a file or something like this, I can pass in another parameter. So I want to build Emacs from an old curl. I will pass it an old curl because it's just a parameter. So you can pass those other programs. And so when you construct a big Linux distribution with a lot of packages, it becomes like very powerful design patterns that you can use to override packages or things like this. So Nix being a programming language allows you to, even like you can say, you can have a binary parameters to packages. So you can say, I want to build Emacs with these options or not, and change this as a user. You can change this from the outside. You can say, I take the expression of Emacs and I override this parameter and it gives me something else. So there are a lot of stuff that you can do. Of course, like it's also not that easy to explain just like this. But Nix being a full-on programming language gives you a lot of flexibility on what you can do and how you can use your package manager.
Okay, good. When you are writing those functions / recipes configurations, I imagine you have like a REPL or something, right? Like you are doing it inside of your environment. So do you have like any introspection tools? Like you can see what the state is, you can test it. Like how is the development like of this specific function or package or whatever?
Yes, there is. So there are several things you can introspect, but so Nix is a programming language. It's also a pure programming language in the sense that you like expressions are like just pure functions.
So pure functional language, you say?
Pure functional programming language, yes. And there are several steps that you can introspect, but the idea is that the first step is the evaluation of the expression in that language, and when you evaluate the expression, you obtain usually something that is an intermediary representation of what the recipe would do to your system. So you write the recipe in Nix, you evaluate this Nix code, gives you a derivation, which is this intermediary representation where everything is done in the text format. And then you can ask Nix to build that or to execute this recipe if you want. And it will read this text and execute the recipe. So usually for a package, for example, once you have evaluated the package and you have the derivation, it will give you essentially like the precise list of steps written in Bash, usually, that will execute, that needs to execute in a certain environment. So it defines also like all the software and the specific version of the software that will be in the environment when you compile, and then the list of steps, and then the expected path in your system where it will produce the result.
Oh, I see. So this derivation, because you mentioned Bash, is essentially the script that will run to do what you ask it to do.
Yeah, it's when you think about a package, it's the compilation script that will run. So to compile, essentially, what you need is the source code first. You need some environment that has a lot of dependencies, like your compile dependencies, your real-time dependencies. So the derivation contains this, like it tells you, wait, the source code you can find at this place, and all the dependencies you can find at those other places, which are already some places on your system. When you do the compilation step, when you build the derivation, you do it in a sandbox, which means that you don't have access to internet, you don't have access to the rest of the system. Like you can, like a Nix build cannot just randomly go read the file on your system. It needs to be precisely declared that it needs those dependencies, and Nix will fetch the dependencies and put them in a specific place and let the build process access that place. And so when you have the source code and all the dependencies in a place, then you only need the build script, like the script that needs to execute to build, and that's it.
Okay.
That's what the derivation is essentially. But it could encode other kind of workflows, but for building a package, it's like this.
And these derivations, can you somehow configure their format, like for example how they are written, or what language should be preferred for the script, because you mentioned Bash? Like, could I say, okay, you know what, Bash I don't like, let me use Python or whatever?
I mean it depends if you mean practically or not. So in Nix package,
so let's say theoretically first.
Theoretically, you can, yes.
Yeah, okay.
But in practice, like in Nix package, all the packages are written with the standard environment that execute the build script in Bash.
And is Bash a choice out of a pragmatic consideration because it's the de facto standard as a Unix shell, or because of some underlying advantage it has?
I think both. I think historically, like it was a compelling choice because a lot of build scripts are written in Bash. But there is also another reason that is interesting, is that Nix package is what we call a bootstrapped distribution. So what does it mean? It means that when I'm building, let's say HTOP or Emacs, I need to build the dependencies of HTOP or Emacs first, and they all form a graph. Like, because you can imagine, when I say that it's written in a functional way, it means the expression for HTOP is going to reference the expression for all the dependencies of HTOP, which is the mechanism that makes it such that you can go back in the past to an old version of HTOP very easily, while it's not that easy to do that in other distributions or in other cases, because like in a lot of software distribution, when the dependency moves or get updated, it's complicated to go back to old version of dependencies. Yeah. But with Nix package, you imagine Nix package as a big collection of expressions. And let's say I want to build HTOP 3.5, it's going to reference, for example, a certain version of GCC or whatever. But if I come back to the expression of HTOP of 5 years ago, it's going to reference another expression of GCC, just like, it's going to be a graph of expressions, which means that it's going to reuse the old GCC and everything, which is cool. So it means you can go back to the past pretty easily, and all the dependencies that were used at the time will also be used, even if I were to go back to some expression of 5 years ago. Mm-hmm, mm-hmm. And so it means, so if you imagine the graph of packages, it means that to build HTOP, you need all the dependencies of HTOP, and you need something, and you need something. And at the root of all things, there must be, there is the root of this graph, which is the thing, the minimal amount of binary or compilers that you need to compile all the rest of the graph, right? Mm-hmm, mm-hmm. So in certain other distribution, you could say, oh, it's fine. I will compile this this new version of GCC, for example, that we want to distribute with the old version of GCC, and you can kind of like break the dependency problem. But in Nix package, it's each time you update Nix package, it's like you start from scratch. You need to start from the very top and then do everything until you have built all packages. So this is called, like, it means you need to bootstrap the distribution, right? You need something at the beginning that is enough to build like something else and build something else until you can build like a modern version of GCC that can then build everything, and you're good, right? Mm-hmm, mm-hmm. And so all this to say that it means that you need to build the scripting engine that is embedded into the building environment of Nix package to be very simple in terms of in terms of software complexity. Because if you start using something that is, for example, based on Rust, it means that to start building Nix package, to start going into the standard environment of Nix package, you need first to build Rust. But maybe to build Rust, you need everything. So you see, like we need to start with something that is very simple in terms of software complexity, and then go further and further up in the complexity layer of software, and then after a while you can build software that has very complicated dependency structure. So I think Bash works well in that regard.
Yeah, because otherwise, to use the example you used with Rust, you would start with Bash until you reach the point where you can use Rust, and already it sounds impractical.
Exactly. And all this thing has a very big consequences in terms of security. Because do you know about the trust problem?
Tell me about it. I think I've heard of it, but it's better to hear and be sure.
It's like it's a mind experience that was, I think, like described by Ken Thompson. And the idea is that, let's say at some point, somebody infected a compiler, a binary of a compiler, in such a way that when this compiler compiles normal software, nothing happens. It compiles normally. But when it compiles new version of itself, so let's say somebody infected GCC a long time ago, and when GCC compiles GCC, it gives the vulnerability to the next GCC. Okay, and so this vulnerability can propagate to modern times. And let's say maybe it's also like programmed to, in 2026, start putting nasty vulnerability in everything, right?
Mm-hmm.
And the idea is that it would be complicated to detect because the hypothesis in this scenario is that it's tough to understand what a binary is doing. When it's in the binary format, you're kind of you have less tools to understand if it's going to do something problematic or not.
Mm-hmm.
So you can be sure of the source code. You can say, oh, I read the source code of GCC. It's okay. But when you have a binary, you don't know what it's doing. So you need to be sure it's been compiled from the source code. But if long time ago somebody said, oh, trust me, I've compiled GCC from the source code, this is it, and it has this behavior, then we wouldn't be able to detect it. So it's called the trusting trust issue.
Mm-hmm.
And it's and the trusting trust issue comes into play into Linux distributions, like essentially any Linux distribution, because to compile your Linux distribution, you need to start from something, from a compiler, right? Mm-hmm. So even with Nix package, we have the bootstrap, the root of everything. It's not source code, it's binaries, because you need to start with binaries, and you cannot produce the binaries out of thin air. And so the thing that you want is that this root, this starting point, this binary starting point, is as simple as possible. Like software that is as minimal as possible, so that you can audit it, maybe. And there's some great work with the project that is called Bootstrappable Builds, which is essentially like the twin brother of reproducible builds. Is the idea that some people work to have like a build chain that starts from a binary of like 200 bytes, a very, very small binary that you could read it and maybe say yes or no, it's good or it's not good. And from this very simple binary, what you do is you compile a very simple compiler, very, very simple compiler. And then with this first compiler, you compile a bit more complex compiler, and so on and so on, until you are able to compile a modern GCC. Mm-hmm. And so the people of the Guix project, so Guix is the other functional package manager out there. They did this, and I think it's a very impressive work. Uh-huh. So now they are in a situation where they start with from something, you cannot avoid it, but this something is very, very, very small, and you could read it entirely and be happy with it. And then it only compiles source that is supposed to be audited by a security expert until they are able to compile a real compiler and go on to compile the rest of the distribution.
Yeah, that's amazing, of course. Does Nix have that? Because you mentioned Guix having it.
Yeah, so what we did is we were like, oh, Guix did an awesome job, let's just copy it, because Nix and Guix are very similar in terms of philosophy, so there is a lot we can reuse. And there is work ongoing, but we don't have it yet. Instead, we have a big table with a lot of binaries that are opaque, that we need to trust, and we start from there. So, there is a big improvement margin for Nix by just re-implementing what Guix folks did, and it's ongoing work, but it's not finished.
Yeah. But of course, this is interesting cross-pollination, because if I understand the history right, Nix started first as the PhD work of the author of Nix, a Dutch programmer. Yeah. I forget the name.
Elko Dolstra.
Okay. So we will write that in. Yes. And then basically the Guix people read the research and were like, okay, great, let's do it in Lisp language. And then the two projects have coexisted since then, basically. That's
So I don't know exactly what prompted the idea of forking. If there was some difficulties working together that prompted the creation of a fork, but Guix doesn't have exactly the same philosophy as Nix because they are GNU. So they are only distributing free software, which is has a very large philosophical difference with Nix. There is a technical difference of using Guix instead of using Nix, and there is no, that's about it. But what is interesting is that Guix is used a lot in the French research ecosystems because it was created by a French researcher. With one target audience that is HPC, so highly powerful. Thank you. Yes, high performance computing. I always forget it. So they have a lot of they have a repository where they have a lot of specific purpose software for this kind of audience, and it's really interesting. Mm-hmm. And as you said, there is some really cool cross-pollination between the two projects where they do a lot of they do some interesting things with respect to software supply chain security, and then they have also I would say Nix package is a huge software repository. We package everything. Which means that there are things with high quality level, things with less high quality level, and that we had to take engineering decisions that reduce the quality of the software repository as a whole, just to have more software. So, for example, there is one thing that is interesting is that one of the big strengths of Nix is because of this graph structure and this functional structure. What you can say is you can take a full NixOS system, for example, and you could, let's simplify. You take a software and you want to know exactly what is the dependency tree of this software.
Okay.
This is very simple. It's just taking the Nix expression at the end and walking through the graph, by looking at the dependencies. There are other Nix expressions, so you look at every dependency, and you again look at the dependencies of the dependencies. And this is a simple task in the functional package management world, which is not particularly always easy to do in other paradigm. And it allows you to create what's called software bill of material, which is a document that lists all the dependencies of a project, right? So that's and it is starting to be asked by every government. We need software bill of material. We need software bill of material. So with Nix, software bill of materials are easy to get, but in certain ecosystem, for example Rust, Rust with these log files. Or Node or Go
or Ruby does it as well.
All these languages that have a log file with thousands of dependencies. To package those software, what we did is we said, okay, we are going to make one Nix expression that fetches all the dependencies, and so there is one package containing all dependencies, and one package that use this as a dependency and compile everything. But the problem is that because we do that, we cannot compute the software bill of material easily, because now we will go and see that there is one package that is called dependencies of this package, and it's a big chunk of stuff, and you don't see what is exactly inside. So we did this for engineering reason, because now it's easy to package all this stuff, even if there is thousands of different versions of the same dependency, because this project wanted this Rust dependency at this version, and this project wanted this Rust dependency at this other version, and so it means that we can have them all. It's easy, but we lose some good property of the model.
Okay.
Guix people, they said, no, we're not doing this. We are not losing the good property. We will make the work of packaging every independent dependencies. Maybe some have only one version of each dependency, which means that maybe some software will not work. We will not be able to package them. So they were we stand with the philosophy of the model, and even if it means we are missing some packages.
Okay. And
So yeah, interesting approach.
what are the possible downsides? Because of course I understand the pragmatic approach of Nix in this regard.
Yeah.
What are the potential downsides of this? Could this become too opaque, where you start to lose a lot of the bill of materials? A lot of the insight you have from the bill of materials, and at that point your system doesn't really make sense, or what could be the downside?
Okay, I think like this downside that I said is like one of the downside of like the approach that engineering approach that have been chosen in the Nix package repository, but it's still like an exception and not a rule. And I think like still Nix is like for this kind of purpose is like way more powerful than a lot of the other solutions that I see out there. There are some, like for me, the real downside of using Nix is like it's not going to work well in some situations where you just want things to work. You need to buy in the philosophy and do the work. So for example, in Nix, you cannot just take a binary that you found on the internet and run it. Because Nix is breaking a lot of assumptions that exists in those binary. So you have to like you if you want to use a certain project that you find on GitHub and you see that they give a binary, you cannot just download and run it. It will not work, and you have to write Nix expression to build it from inside Nix, essentially. So, but it doesn't like it deters a few beginners that are like, I have this expectation of what I can do on a system, and it's not working with me. So it can create a lot of frustration, right? But when you start buying into the philosophy and doing stuff the correct way, I would say, after a while, you just find out how it improves a lot of your workflows, in my opinion.
Yeah, and I can imagine this kind of beginner who is nevertheless committed. Now they have a good reason to learn how to package that thing so that they have it in Nix.
True. Yeah, the question is, do they stay, or do they say, this frustrates me. I wanted to do something that usually takes me 3 minutes, and now I need to work hours for it.
Yeah, of course.
Which is like, it can happen. Like it happened to me at the beginning. I was frustrated a bit, but I stayed implicated, and then I found out how you should solve these kind of situations.
Yeah. I think it's good as a community also to set the expectations, right? Like, well, there is a learning curve. You will do some work, but eventually these are the benefits. So that people don't have this tourist-like mentality where it's like, I will just switch to Nix over the weekend and I will learn everything.
I think as a community we are pretty bad at this, setting the expectation right. We have there is a big learning curve, but we are lacking in terms of good documentation for beginners, or good giving the right direction for people to go find resources at the right place. So this is something I'm trying to improve as well.
Yeah, and of course it's a collective effort. Because I have seen Nix and Guix being mentioned in all sorts of places, but I rarely see the fact that, hey, this is actually not that easy. You don't just install it like every other Linux distro.
Yeah, it can be frustrating if you think the path is going to be easy, and actually it's not. And so, yeah, we need to manage expectation as well.
Mm-hmm. And of course, the fact that Nix is a programming language has its own learning curve, because you don't just look at the package and you know how to write all packages, right?
Yeah, and I think like people are underestimating this part of the learning. They are always like they are seeing Nix code, and Nix code looks like a bit like JSON code, like just settings, like you were setting in configuration, because Nix works a lot with a structure that is called attribute set, which is just setting. It's like a Python map, for example, and you set, like, you say this key equals this value, and you do a lot of this, right? And so when you're beginners, like, one big trap could be to think that, oh, okay, it looks like a simple configuration. It's not that complicated. So they don't take the correct amount of time to learn the language, and they directly try to do pattern matching in their head. And then if you do that, you have like some kind of glass ceiling that prevents you from like really understanding. You can probably, and the problem is that you can probably go places with just pattern matching. You're like, okay, it works a little bit, right? And then at some point it doesn't.
Yes, and then you run into trouble, and suddenly you don't know what is happening. How to?
Yeah, exactly.
So somebody who wants to start with Nix, what are like the first steps? Like, what is the good practice, the good way of starting with Nix? Let's say as a fully fledged distribution. Let's not think about on top of Mac or whatever. Let's say, okay, I want to install it on my laptop.
I think like one important thing is like not just saying I want to do Nix or I want to do NixOS or things like this, but have expectations of why you want to do it, why it will, like, what it will bring you, and there are like quite a lot of different angles where it can help you. So you could adopt Nix as an open source developer, and what it would bring you is to be able to have a development environment that you can define and share with coworkers or share with your users or things like this. You can also, as a developer, imagine like that you want to distribute your software through Nix, and so it means that you can write an expression that will build your software. And then this expression can be used in like one line of one command by users to try your software without having to even put your software inside a distribution. So like for open source developer, you could want to adopt Nix for those reasons, and in this case you don't need NixOS, you just need Nix. For a user, you could like try to, you could say, I want a package manager, just a package manager, in which case you can enjoy the work of the developers that did the other part of the work. But you could say, I want the distribution and what it will bring you, like better control on what is installed.
Yeah, sorry. Let me add the battery thingy. Okay, yeah. Sorry, please continue. Yeah.
It would bring you a better control of what is happening on your system, what is installed. I think also better understanding of how a Linux machine is designed, how it works. At least it did for me. Like, I learned a lot of the primitives under Linux, like how like different. For example, one thing that you like when you configure a NixOS system, you have like those options, and there is a website with all the options that you could set. And the idea is like in Nix, you activate or deactivate options. So for example, let's say you wanted to activate, you want to install Nextcloud. Nextcloud is a cloud software collaboration software that is open source. And if you wanted to install Nextcloud, what you would do on your NixOS configuration, you would simply write services.nextcloud.enable equals true. So you have this kind of option that you can enable, disable, and in Nix, and then you can have abstractions on top of them if you want. And the idea is that by looking at all these options, you can also learn better what is available to you on a Linux system to configure. which is interesting. For example, you could learn that if you wanted to set up networking on a Linux system, you could use a network manager, but you could also use systemd network D, which is another thing. So it can trigger curiosity. So when you know why you want to use NixOS, it's important to have like the expectation of why you want to do it, because otherwise, if you don't know why you want to do it.
I lost the connection. What happened? Not good, not good. What can I do now? I closed. Let's go to the. How did this happen? Let's get the history. History. No, here. Let's see. What happened, folks? Oh, sorry about this. How did that happen? Hello? Okay. It dropped, and now it's three of us, so one of us is the imposter, Prot. I don't know what happened. As you were talking, it dropped, and then I accidentally fat-fingered closed the browser, so I'm back. Okay, so now we are back to where we were. Yeah, sorry. You were saying that you basically have to know your use case.
Yeah, you have to know what you expect from it, so that you don't like. If you have no expectation, then I think there is a bigger probability that you will just abandon the ship at the first problem. When you know why you're motivated to do this thing, and you know that there is a large learning curve, so it will be painful at the beginning. When I would recommend reading a few resources. So one resource is the Nix pills, which is a series of tutorials that explain you a bit a few design patterns of Nix and how Nix is designed in the lower levels. There is some tutorial on nix.dev that are pretty good as well. But the biggest problem in Nix is there is not one resource that goes gives you a end-to-end path from I don't know nothing to I am in a position where I am autonomous. And so Prot, you already know about this, but I'm trying to create such a resource. I'm trying to write a book. I don't know exactly what's the timeline for it, but we have a problem in the Nix community where we don't have one good resource for beginners to use, and I'm trying to. I'm someone that really likes transmitting my knowledge. That's also why I do research. I've done a lot of teaching, and that's one reason I'm trying to write this book.
Yeah, of course, and good luck with that. And I think having such a resource is good for the onboarding, and it's also good for what we discussed earlier, where we don't do enough in terms of setting the expectations, that sort of thing. Because then it kind of sets you straight. It's okay, here is the progression from beginner to advanced
exactly.
user. Yeah.
Exactly, because the problem is as you say, you can read all the resources that I just talked about, like the Nixpill and Nix.dev. You can probably read them all in a few hours, and then you're okay, am I an expert yet? No, you're still a beginner, and there is a lot of things lacking, and then you have to find all those gaps into your knowledge. You have to find all the individual resources that do exist and that address it, but they are scattered everywhere. And you know them if you've been in the community for several years. You know the good resource to learn this and to learn this. But if you're a beginner, you're just lost, and you start getting frustrated.
Now, of course, if you are a beginner to Nix, what about the kind of user who is experienced in the Linux world? Let's say somebody who has used Arch, who has compiled the software from source, all that stuff, who has played around with the computer for a while. Is this kind of user, who we would consider a power user in the Linux space, is this kind of user going to have an easy time switching to Nix? Should they be smug about it, like, oh, I use Linux Arch, by the way, now I can just use Nix easily? Or are they also going to be humbled and they will be beginners?
I think they will have easier time than beginners, of course, because especially when you know a bit how like compilation of packages work and the vocabulary around it, probably is going to make it way easier to understand what is it that Nix does behind the scenes to compile the software. If you know a lot of how Linux distributions or Linux system work, it's going to make you in a way better position to understand all the options that NixOS offers. But there is still, in my opinion, that the question of learning the languages and how the whole system is designed, that is going to be an important step. But I mean, okay, it's not. There are a lot of people in my surroundings that have learned Nix, and you don't need to be a genius. Everybody can learn Nix. It's just like the learning process could be made easier, but still, like I wouldn't say to anyone, no, you should not learn Nix, it's going to be too complicated. I would say, oh yes, you should learn Nix, it's going to broaden your horizon a lot, and read this, and I will help you. I will hold your hand for you to find all the good resources you should read, but it's going to be fine.
Okay, very good. Tell me a little bit about your teaching work, if you don't mind. Like, do you teach this kind of subject, or do you teach computer science in general, and this is kind of a small topic?
Okay, so first, I've done a lot of teaching during my studies. Like I've been studying in Switzerland a few years, then in Paris, and in both cases, like teaching was a way to earn a bit of money during my studies. So that's one of the reasons I did it, and also because I always had a great pleasure teaching people and trying to transmit my knowledge. I think like teaching is really an interesting task, because like it's not that easy to make someone understand something, just because it's not just about you, it's really about them. Like everybody understands concept differently, and if you're only trying to explain it the way you understand it, probably it's not enough. So there is some kind of also problem-solving skills that are involved, because you have to find the correct angle for the concept to be understandable by the person you're teaching to, and also you have to put yourself in the position of the person you're talking to, because like when you have understood the concept, you quickly forget why it was complicated to understand in the first place. So like it's fine, I've learned Nix now, I've been several years in the community, so one difficulty for me to write the book or to like teach Nix is like trying to remember what was confusing for me at the time, and in like what was the state of my knowledge when I tried to learn Nix, that it made it complicated. So that they are like two actually pretty difficult problem to solve. So I always found it very interesting to do. I've taught so university students, like university topics. I've taught some young people programming. So I did a lot of teaching of Python. So I was like working in summer camps where I was taking some teaching to some kids, like maybe 12 years old to 15 years old kids that had no knowledge of programming, and I was teaching them Python, and after a week they were able to like code a simple game like a Tetris or a Pong game, stuff like this. So it was really fun. And I've also taught a bit Nix to mainly to professionals and to my friends. So that's I've taught a lot of different things, but it's always a pleasure for me to do it. So that's also one reason why I decided to go into the research or into academia, because I think at the beginning the main driver was like, I want to teach, I like it, and then I was unsure if only teaching was going to be like challenging enough for me, because the problem with teaching is like all those problem solving skills, you mainly work on them a lot the first time you're teaching a topic, and then can become a bit repetitive. So I was like, I don't want to do something that is too repetitive. So, but if you add the other part, which is research, where you keep your brain, you keep it with tough problem to solve, you can do half research, half teaching, and I think it's a good balance.
Yeah. Sounds right. Because I imagine then it gets a little bit boring to do just teaching.
Yeah, I mean, some people do just teaching and they're perfectly happy doing so, but I was like scared of it. Scared that it might like be unbalanced and be boring after a while. Yeah.
Tell me a little bit about the situation with the tech side of the academia in France, because I get the impression that there is a lot going on in terms of open source, free software. Like you mentioned earlier, the Guix developer, the creator of Guix, who is French. I know many other people who are French and are contributing to free software. Is there something like a demand from the government or from the officials for free software or for, I don't know, digital sovereignty and these sorts of things? Or it just happened and many people in France just coincidentally have these interests?
Yeah, I think like the question of digital sovereignty is becoming like a bit of a political question in France, which I mean like the political or the policy people are starting to understand why it's important not to be too much dependent on other on commercial software that is provided by other countries, like um, too much dependent on Google or Microsoft. Personally, I've worked in French ministry for 6 months, and I've seen that like there is a lot of software that is being used where there is this kind of dependency still exists. But recently, I must say that there is this topic has become more important. And for example, there is one thing that the French government is doing that is, I think, pretty cool. Is they are developing a collaboration collaboration suite that is called La Suite Numérique, that is based on open source software. So they have, like, for example, they have a spreadsheet tool that is based on Guix, which is open source software. They have a video conference tool that is based on LiveKit, that is actually been designed internally, that is now open source and self-hostable and everything. So it's like, for me, it's the future of Jitsi. And they have other like made internally tools that are part of La Suite. Recently, there have been like also like they're trying to collaborate with other European governments to like maybe share some of the development workload of this kind of stuff. So it's very interesting, and it shows that there is like there is a will to try to get more independent and use open source software and participate in the open source software, which is really cool. Like it could be that they are just using open source software and deploying internally, but no, they are actually in some cases leading the development, in some other cases just contributing, but then deploying it for the government. So it's really cool. In terms of the research ecosystem, I think there is a tradition or a culture in the French research to try to create those open source software or create those projects that can then foster some research around them. I'm thinking about for example, Coq is it's a Terra improver that has a big community, was created in France, and there was this community that was fostered around it, and other examples like this. So I think in the research area, this idea is that research must not only be papers, but can also be software, and can also be must also be stuff that will be useful for the community. There is some part in the French research where this culture is really present, and for me, when I started my PhD, I really wanted that my research is not something abstract that other researcher will read, but really something that, if possible, will have a positive impact on my software community. So I wanted to do some research on Nix because I was already open source contributor to Nix, and I wanted this research. Ideally, I wanted some other open source contributor of Nix reading my paper and say, okay, this is interesting, I didn't know about it. Or this is a cool idea that I think would be useful for the project. So that was one of my goals.
Yeah. So not keep it confined to that academic bubble.
Yeah, exactly. Because it's really easy to lose this vision and just write papers that are maybe they have a cool contribution, they have a cool idea or cool results for the research community, but no practitioners will ever implement those ideas or read the paper because it's too foreign, too abstract to be usable. Yeah.
And are there research grants on this front? Are there monetary incentives, or is it just a cultural thing?
No, and that's one of the big issue is that there are not a lot of incentives to for example, let's say you're doing a paper, and for this paper you're developing some software. The research incentives would be just to publish this paper, publish the software on open source Forge, and forget about the software ever, because it's probably not going to bring you another paper. So why would you maintain it or improve it or fix the bugs or take suggestions from the users? The incentives that exist in the French research are really publish papers, a lot of papers, as much papers as you can, in good venues, and make these numbers grow. Okay. And not particularly to do a software and maintain it.
I see. So kind of how it is everywhere with the science community.
Yeah.
I see.
Unfortunately.
Okay, but then, of course, the French doing the contributions they do despite those headwinds, I think that's laudable. That's well done.
Yeah.
And of course, you as well. So continue the way you do.
Thank you.
You're welcome. So I say we call it a day here. We wrap it up.
Okay.
Everything you mentioned, those resources for Nix, the creator of Nix, we could include it as links in the description of the video. So if you can, please send me the links, and I will just add them there.
Okay. Well, it was really an interesting conversation. I am super grateful that I could have this conversation with you, because I think you have a vision of things that is really interesting, and I would like to thank you for your work, your open source work, and everything. I think it's what you're doing is really cool, and I like that you're having this conversation that makes it possible for people to discover the work and the vision of other people. Thank you very much.
You're welcome. You're welcome. Let's call it a day then. Take care
Yeah.
and good luck with everything. I will close this and then stop the recording.
Okay.
Take care, Julien. Goodbye. Goodbye. Goodbye.
See you, Prot. Thank you. Bye
Take
bye.
care. See you. See you. Bye bye. Stop here. Stop. Okay. Close and goodbye from my side, folks. Take care. Bye bye.